In this lecture, we will discuss about the normal forms of context free grammar. So, what do you mean by the normal forms? So, removing the ambiguity is not the only thing that makes a compiler stable one. Apart from this, we have to remove the redundancy also from the context free grammar by removing lambda production or removing useless production and removing unit productions. And after removing all those productions from the context free grammar, the refined context free grammar is called they are in the normal forms in a CFG. So, what are the productions that we have to remove? Remove useless production, remove lambda production, and remove unit production. So, let us start with the first one, removing useless production. So, what do you mean by the useless variable? So, useless variables are those variables which cannot be initiated from the initial start symbol either directly or indirectly, or which cannot be terminated. Either it cannot be start from the initial state or it cannot be terminated. Suppose if I write production is to ASB slash lambda slash A and A to AA. Now, for this production, look at this one. So, for A we have two variables, right? One is A, another is S. So, for A we can start A from S from the initial state, but we cannot stop A. Now, suppose if we write an initial state for this terminating symbol for this one, then A will become useful variable, right? But in this case, if I remove this A from here, then what will happen? So, A can be terminated, but A cannot be start from the start symbol. So, in both the cases, it will become the useless variable. So, if we find out any useless variable over there, then remove that useless variable instantly. Suppose let us check one example. S to AS slash A slash C for this production. Is there any useless variables are there? Yes, useless, we have useless variable. Suppose how many variables are there? We have to identify. We have S, we have A, we have C, and we have B. Out of this, B cannot be start from the start symbol. And another way, C can be start from the start symbol, but C cannot be terminated. Well, and another variable is A, which can be started from the start symbol and which can also be terminated. So, A and S, these are two useful variables, but C and B are useless variables. So, what we have to do? We have to remove B and remove C also, and wherever A, B and C appears, we have to remove all those productions. So, therefore, after removing useless variable, B and C, it becomes S to AS slash A to small a. So, these are two production after removing the useless variable. Now, let us see what is lambda productions then. Next is remove Now, what is lambda production? Any production of the form A to lambda is called lambda production. Now, if within your production, if these types of production appears, that is A to lambda, then we have to remove that production. Suppose I have S2 AS1B and S1 to AS1B slash lambda. Now, look at this one here. S1 can be replaced by lambda. Lambda is basically used to terminate S1, right? Now, if wherever S1 appears, if I place the lambda over here and whatever by the strings are generated, these are the alternative terminating symbols for S1, I can say. Now, if I can replace with those alternative terminating symbols instead of lambda, then the lambda, the purpose for which lambda has been initiated, that is not required further. So, here we will do the same thing. So, we will find out that where lambda can be used, and we will replace we will use lambda over there, and whatever the terminating strings that will be generated in place of lambda, we will replace the respective places with those terminating string, and so that we will get it. So, let us check that. Here S1 can be replaced by S1 can be replaced by lambda, right. So, wherever S1 is present, here S1 present and here S1 present. So, here if I place lambda over here, then I should get AB. So, I will place over here AB wherever lambda is required, right. Here also if I place S1 equal to lambda, I should get AB again. Now, these are the two places where I should use lambda instead of S1, and I will get AB. Now, AB is the alternating string in place of lambda. So, if I place over here AB and AB over here, then there is no requirement of keeping lambda for this purpose. So, these are the basic purposes for which lambda is required. So, we have replaced that purpose. So, lambda is not required furthermore. So, in this way we will have to remove the lambda. So, let us see one example. Now, where lambda is present, first identify this one. Lambda is present at B, lambda is present at C. Now, wherever B and C is there, try to place lambda and check that what are the strings are being generated. Now, here if I place lambda, then I will get BAC. Here if I place lambda, lambda is there in B and C, right. Okay. Here if I place lambda, then I should get ABA. Even it may also happen that lambda, I am placing lambda both in A and both in C simultaneously. So, that case what will happen, sorry, not A, both in A and C simultaneously. That case what will happen, B and C both will be lambda, that case A will also be lambda. So, it is not like that if I place B and C lambda, then I will get AA. So, I will get only small a only, because capital A will not be present that case. So, if I place B and C both lambda, then I should get only small a, and I will place over here BC, and I have to keep the provision that if I put B equal to lambda, then I should get C. If I put C equal to lambda, that case I should get B only. If I put B and C both are lambda, that case I should get A equal to lambda, that I will not I may not require. Now, why to keep this B C then? Because apart from lambda, B has another production, that is small b, I can use that one, and C also another production, that is capital D, which will ultimately resulting you to give the value small d. So, for this purpose B and C both are required. Now, lambda has been replaced. So, here lambda is not required anymore, here also lambda is not required anymore, and the ultimately another string is d equal to small d. So, we have removed the lambda. Let us see now the unit production. Any production in the form is called unit production. Suppose if I give an example, S to AAB, A to capital B, B to capital C, C to capital D, and D to small d. Now, only terminating symbol here is that D to small d. Now, wherever C to D, I can replace this D with small d. Wherever B to C is present, I can replace this capital D with capital C with capital D, ultimately which will lead me to small d. Wherever A to B is there, I can replace this B with capital C, which is ultimately replace C with capital D, and ultimately it is small d. Ultimately, what happens that I can replace this A with small d. These are the productions are not required, because this is giving the same value, same variables that B has. B has the same value that is C has. C has the same value that is D has, and D has ultimately small d. So, I can replace directly to small d. So, these types of productions are called unit productions, which are not required, which are actually redundant productions. So, I can remove those productions easily. So, I have to identify those productions wherever it appears, and we have to remove it. Now, let us see one example. Now, here we have to identify how many unit productions are there. A to B is one unit production, B to A is one unit production, and S to B is another unit production. If you have multiple numbers of unit production, in that case you have to take the last unit production to remove it first. Last unit production is A to B. Now, that case how to remove it? Whatever B's production, B's replacement is present, we have to replace this one over here wherever B appears. Now, first replace this one, but in that case also you have to write down all the productions step by step. Now, here A to A, that is the same productions appear. So, this one is not required. So, we can remove this production. Okay. Let us first write it and then remove it, that would be better. Now, ultimately we have this one. Now, next one is we have to remove B to A. So, wherever A's productions are present, we can remove it through this one. So, if I remove it, then it becomes S to AA slash B, then B to I have this entire productions A to BC slash BB slash BB, and A to A BC slash BB. Now this one is also redundant one, so I can remove any one of them. So ultimately what we are getting out of this, we can write it down over here. S2 AAB AA slash B then A to A BC BB and B to A BC BB. Okay. Next, my third unit production is S to B. Now replace this B with B's production. So what I will get, S to AA, then A BC BB, A to A BC BB, A to A BC BB. So after replacing this one, we will find out that B becomes useless, because B is not initiating, B cannot be initiated from S. So we can remove B easily. So if I remove B, then the ultimate my productions after removing the unit productions and useless productions, it will become S to A to B, A to A BC BB. So this is my ultimate result. Now we have seen that how to remove the lambda production, how to remove the useless production, how to remove the unit production. But the question is that if a grammar is given to you and you are asked to normalize it, which production you should remove first? If you have unit production, useless production and lambda production, all of them. So there should be a sequence. So if you remove the useless production first and then unit production, you will find out then again some useless production will be generated. So therefore you have to maintain one sequence. Sequence is that first you have to remove the lambda production, then useless unit production, then useless production. So remove lambda production first, then remove unit production, then remove useless production. So please maintain this sequence. So let us see with some more example. Normalize the grammar. So when you are being asked to normalize it, you have to first check that whether there is any lambda production is present or not. Here no lambda production is there. Now is there any unit production? No, there is no unit production, because A to B to AA is not an unit production. If it is B to A only, then it will become a unit production. Then we have to check, is there any useless variables are present. So look at this, how many variables are there? S is one variable, A is another variable, B is another variable. A and B both can be start from the start symbol. Now can they be replaced? Can they be stopped? So none of them, A and B, cannot be stopped. Here I should put one lambda also. So A and B, none of them can be stopped. So both are useless variables, and I can remove this both A and B, and wherever A and B appears. So ultimately my result will become S2, after removing A and B, it will become AS2 AS slash lambda. It's very easy. Now let us see another example. So, to normalize it, first we have to check that is there any lambda production present. Yes, there is one lambda production is there at A. Now, wherever A appears, just replace this A with lambda. Then what are the strings generated? Let us check. Now, if you place lambda over here, you should get S2A only. So, there is no need to write S2A because S2A is already present. So, you can replace this one easily. Now, let us give A to B, and for A to lambda is not required furthermore, because we are providing the alternative productions for A to lambda. Now, in this case, if I put lambda over here, I should get B only. Now, after removing lambda, here I should write remove lambda production. Okay. So, what are the strings I got? Let us write it down again. Now, remove unit production. Now, we need to identify is there any unit productions present. Yes, we have two unit productions, right. One is S to B, another is S to C. Now, replace all those things S to A to AA. Now, if we replace B, then you will get B production is AA is one of them, another is small a. Small a is already there, so we need not to write it down again. Next is C. C is small c, capital D. So, these two unit productions are being removed, and write down the other productions. Now, let us check. Already unit production is removed and lambda production is removed. Now, is there any useless variable? Remove useless production. Okay. So, we have two useless variable, I suppose. How many variables are there? Let us check. S is one variable, A is another variable, C and D and B are other variables. Out of this, B cannot be initiated from the start symbol directly, but it can be initiated indirectly. Fine, and B can be stopped also. And A can be initiated and A can be stopped also through B. And then C. C can be initiated from the start symbol, but C cannot be stopped. And then D. D can be initiated as well as it can be stopped. So, only useless variables is C. So, you have to remove C, and wherever C appears, you have to remove that one. So, after removing unit production, useless production and lambda production, I am getting this ultimate result. This is the ultimate result. Let us see another example. Now, in this case we have two lambda production, one is for A2 lambda another is B2 lambda. As A2 lambda is only the terminating, so A2 lambda we can remove easily by giving the replacement. So, if I provide A2 lambda, then I should get AB, and if I give B2 lambda, then I should get AA, and if I give A and B both lambda, then I should get small a only. Here also AAB, and if I give lambda over here at B equal to lambda, then I should get AA only. Now, A lambda should not be there because already I have removed this one, but for B I should get BBA as well as BB when I am putting A equal to lambda at BBA, right. Now, remove, is there any unit production? No, there is no unit production, so I need not to write it down. I can write it directly, I can write it directly that there is no unit production. Next is now look at this, is there any useless variables are present? Yes, A can be initiated from the start symbol, but A cannot be stopped because A's productions we have already removed. So, wherever A appears we have to remove that one, but B will remain and B can be initiated from S and B can also be terminated. So, we have to remove A wherever A appears, but we can keep B. So, this is the ultimate result. Hope this is clear. Next is question number 4. Now, first remove lambda production. Now, lambda is present at A2 lambda, right. I can put S to A, then A2 lambda is not required at S. Here I can put it S to AA, and rest of the productions will remain as it is. Next is remove unit production. Now, I have to identify that wherever the unit productions are present, C to B is one unit productions. So, by replacing the productions of C, I can do the same. Okay, my unit production is being removed. Now remove. Useless production. Now I have to identify, is there any useless variables are present. How many variables are there? S is one variable, A is another, B is another, and C is another. Now S can be stopped, A can be initiated from S, and A can be stopped. B can be initiated from S, and B also, no, B cannot be stopped. B cannot be stopped, as well as C also cannot be neither from initiated from S as well as, but C can be initiated from B also, but C also cannot be stopped. So B and C, these two are two useless variables because they cannot be terminated in any way. So we can remove B and remove C. So ultimately my production will become S2AA. This one will be removed, then I will get A, and here A2AA, double A, then AA, and these two will be removed. So this is my ultimate productions.